The at least probability is one of the more difficult probabilities to calculate in statistics. This involves using what we call the complement rule that we saw earlier in this chapter. So what I wanted to do in the handout was give you a template on how to calculate an at least probability. This will be a key word that we'll see in a problem, and there's a certain template that goes along with solving this type of probability. So when we see the probability of at least 1, okay, that's the template. Probability of at least 1. At least 1 means that we have 1 or more. So the at least probability requires that we take the opposite of 1 or more. So when you think about what is the opposite of having 1 or more, the opposite is none. So the at least probability requiring the complement rule, we need to apply the complement rule that says 1 minus. Okay, so the probability of at least 1 is a probability that we have 1 or more. By complement rule, the opposite of the probability of 1 or more is 1 minus the probability of none. So we're going to use this template for example 4 to see how that looks like. 13% of individuals are left-handed. 2 individuals are randomly selected. What is the probability that at least one person is right-handed? Okay. So here we see the word at least. Not only that, they're giving us opposite information. Here we have information on left-handed, and then we have the final answer looking for right-handed, right? So they're kind of giving us a hint that we need to use opposite or complement rule somewhere in here. Okay, but the keyword at least will require the complement rule. So let's use a template to see how we begin the problem. So the problem is looking for the probability that at least one person is right-handed. Okay, that at least one person is right-handed. Following the template, that means we have the probability that 1 or more are right-handed. Okay, that's following the template. So now we got to think about what is the opposite of 1 or more being right-handed. The opposite of 1 or more being right-handed, okay, let's call it erase. Okay. The opposite of 1 or more being right-handed is that none are right-handed. Okay, that's the opposite of 1 or more being right-handed. So now notice what we have. The probability of 1 or more right-handed, because we're taking the opposite, okay, we need to apply complement rule, that is 1 minus the probability that none are right-handed. Okay, so that's how this probability will begin, is by using the template in order to use the complement rule. Okay, so let's take a closer look at this piece right here. Okay, so let me rewrite this up here. We have 1 minus the probability that none are right-handed. So go back to the problem. Notice in example 4, we selected 2 individuals at random. So if none of those 2 are right-handed, what must they be? If none are right-handed, they must both be left-handed. Is that right? So then we have 1 minus the probability that both are left-handed. Okay. And there was a similar problem in this section whenever we saw the word both left-handed. If 2 individuals are left-handed, that means that the first person is left-handed and the second person is left-handed. Okay, And notice, what did we introduce in this step here? We introduced a keyword, the keyword being and. We have a formula for and if these two events are independent. So going back to the problem, okay, two individuals were selected at random. So does one person being left-handed have anything to do with the other individual being left-handed? The answer is no, because here they were selected at random. So if they have nothing to do with each other, we have independence. Okay. So by independence, we have 1 minus the probability that the first is left-handed, and then we multiply by the probability that the second is left-handed. Okay. So continuing here, the probability that a person is left-handed in a population is 13%. The probability that a person is left-handed in a population is 13%. Okay, and keep in mind we have a complement rule going on here. So 1 minus 0.13 times 0.13 is 0.9831. So what did we ultimately answer? Okay, so going back to the problem, we were looking for the probability that at least one person is right-handed. Okay, this was the question that we ultimately answered, but the keyword at least required a complement rule in order for us to get there. Okay, so this probability here is the probability that at least one person is right-handed.